we have practiced many sorting algorithm where we plan to write the code of our own based on the algorithm, their logic, and we have also studied Java collection framework where we can store different type of data in the form of collection, and sorting, as I told, or searching. This is the obvious what is called the two operations in many applications. Considering this, so Java developer includes sorting and searching algorithms as a part of, as a bundle of the different methods in order to deal with the collection. So, today in this discussion we will discuss about how the sorting techniques supported by the Java collection framework. But before going to this Java collection framework learning, first we have to discuss about the merge sort, which is one very interesting sorting algorithm which we did not discuss about it. So, let us first discuss the merge sort, and then finally we will discuss about the sorting technique which basically supported by Java collection framework. So, first let us discuss the merge sort. As you know, merge sort algorithm is basically based on divide and conquer, where we have to divide the two lists almost equal to two parts, equal parts, and then recursively call the merge operation, and then finally merging them. So, there are recursive definition of the merge sort is to be done. We have discussed about how quick sort technique also can be defined recursively. It is basically in the same way we can do it. So, this is the algorithm that you can think for merge operation. It is very easy operation actually. Two lists are there, we have to just move the pointer from the two parts of the list and then finally combining the results. So, this logic you can follow from the algorithm, otherwise you can write, okay, this logic is important, and then this is basically the technique, that merge sort, how recursively it can be defined. So, you have to find the mid calculation, how the mid calculation can be done using this floor, and then you have to call recursively the two merge sort, and finally this is the merge operation you have to do. So, this is most important, and the algorithm we have already given in the last slides that you can follow. Otherwise, I can give you one logic, one implementation of these techniques, first merging and then the calling of merging towards the merge sort implementation. Let us see how I solve the program. So, this is one example that I want to give it. So, this is okay, generically I declare a class, these are all things it is there. Now, these are two lists that we require it, that means it is the array that we can declare into two parts. So, basically n1 and n2 are the two lists, usually they are of same size anyway. So, this basically is the past. So, m and r, m and r is basically if the two list is there. So, it is basically L, it is R rightmost, and the middle m will be calculated. I will tell you how to find the mid m value then. So, this basically whenever you call this, you have to pass it, and so this is the merge actually operation, because we have to perform the merge operation on the same list. So, basically this is the part of the list and this is another part of the list. This is again sorted out by calling the merge sort recursively. Finally, when merge sort come back, and then it will basically give sorted list and everything. So, this is basically the one part, as I said here. So, this is the one part and this is the another part. So, this is the D1 part we can say, and this is the D2 part. Now, they are basically on the same array, that is why I just made it this kind of arrangement. Anyway, so this is basically the, okay, we can store this in two different array also, copy, and then that is what the practice we usually do. So, make them copy into two lists actually, they are of type same T. Then we can do it here basically how this is just copy the part of the list into two sub list that we have done. Otherwise you can do on the same list also. That logic is little bit okay, you have to maintain it little bit cleverly, otherwise you can make into some error. And here is the code that I have given here, okay, continuing the same procedure, how we can compare the two elements, those are required to compare this there, because merging is based on comparison is there. So, here we just copy, here is this is basically the merge operation that we can take from one element to other element and then putting into the list there, and it is basically at the end one list can be empty and other list may contain some data. So, basically copy elements with there. So, this basically the idea about merge operation. Then we can think about how the merge sort technique can be implemented. So, here is the code for writing the merge sort method here, and this is basically quick sort implementation. This is the termination condition. We call the merge sort for the two parts dividing this one, right. Here is basically you see how we find the mid location, right. So, this is the simple logic, and then once it is there we call this merge operation. This is the logic that we have discussed, the same procedure we follow here. And finally, this is an auxiliary method to print the elements. So, that is all about the merge sort implementation. Is the programming logic, you have to follow it little bit, okay, take your own time, because for understanding others program sometimes it is very difficult, right. So, that may take some time. Anyway, you take your own time to understand the code, and here is the demo program. So, this is the demo program, that how the merge sort works. We have considered this list as an input, and then we call the merge sort method. So, it return the elements list, and then we just print the element here, right. So, here we just create an object of this program. So, that is why OB is basically calling the merge sort, and then we can print the elements. And okay, so there is another example. This is basically to takes the merge actually. So, you can test that how the merge operation work also, that you can think about it. So, these are different way that you can think about how the merge operation can works. So, take your own time to understand the code. You can initially run the code that you can, it is working, that okay, then you can finally practice it. Now, finally, let us come to the discussion about the utility so far the sorting method is concerned in Java collection framework. There is a collection, the name of the collection is arrays. In this collection array only implement the sorting method. There is no other collections which has its own sort implementation. It may be little bit peculiar, but it is actually there is a purpose, because any collection, whether it is array list or it is a hash or is a tree or any type, you can convert it into arrays. That already I have given example how a collection can be converted into other collection. So, using this concept you can just convert into an array, then finally you can call your what is called the sorting method there. Unlike other things, that is okay possible that for I do not know why the different collection they did not include the sorting method in its framework there. Anyway, but this is the only thing is that they wanted to make it one implementation, and again which sorting algorithm that the Java collection framework implements, that is also not known to us. So, possibly it implements the quick sort technique, because quick sort is the most efficient sorting technique, other than if it is not sorted, and assuming that list that needs to be sorted usually rare to have in the ascending order, that is why. Now, so far this utility is concerned, okay, as I told you, it is declared in arrays, and in the class arrays there is one method called sort method. Possibly we have, you can remember this class arrays also declare one searching algorithm, that is binary search. Only the method that is that implements the binary search algorithm, because it is the most proven and standard algorithm for searching. Like this also sorting, quick sort is implemented possibly. It this algorithm sort the elements into ascending order. Now, so far sorting is concerned, it can sort any type of data. Now, here you see the sorting algorithm that the different methods are there is basically you can pass argument to the sort method is an array of bytes. So, here basically sorting the binary numbers, basically sorting array of characters also you can use it, and is a double, float, integer, long, short. So, these are the all numeric types that you can sort using this method. And then there are some sorting method also, you note it here. Object mean any user defined type you can implement, right. But whenever this object you want to use it for some on your type, then you have to override compare to, otherwise it will fail, it will not work for you. So, here the object is an argument type. This means that this method sort can be invoked for any type of data, any user defined type of data. So, for your defined type of data you have to override the compare to method, that you should do. And it also okay. So, the generically this sorting method is like this. So, it is defined generically, it is like this anyway. So, these are the concept that you can think about it. So, how the sorting it works. Now, we can have certain demonstration about how we can call it. I can okay, before going to discuss about demonstration, in this class arrays there is also one technique or method is defined. The method is called parallel sort. This is the most efficient sorting ways, but it basically it is possible in Java. This is because Java can follow multi-threading. For example, in case of divide and conquer, you can do many operations in parallel, because here the recursion, two recursive routine can be executed in parallel, which again recurs up to recursion. So, 4 recursion can be executed in parallel. So, if you want to sort very large set, then definitely you can use the parallel sort method to sort it. For smaller set you cannot find it, but for large set. Now, to test very large sort, I can suggest you to create a very set of large numbers or random numbers into a file, maybe say 20,000 numbers. That random numbers you can generate within a certain range, and then you can call this parallel sort. Now, like simple sort, this parallel sort has this okay byte array, you can character array, double, float, integer, long, short, or any other type of user defined array also you can use it here, because it is also support user defined type. So, this parallel sort is basically equivalent to any sorting algorithm, but only it is basically to do some parallel programming using threading, and it solve it, and it is an efficient. Usually this method will be called if you want to sort very large data. Whenever you have to develop some application where you have to deal with very large set, then definitely you can call parallel sort for any collection. So, if it is any collection, then you can convert this collection, copy this collection using only one statement, that you can copy as list into arrays, and then you can get the element, and then array can be there. So, then you can use it anyway. So, this basically the idea about the two different methods which are defined in the class arrays. Arrays is defined in Java collection framework, for which you have to import java.util if you java.util while you are writing program. Now, let us have a demo so that you can understand about how you can call it. So, here basically I am giving the demonstration about using the sort method, array sort, and we declare an array of integers here, and then in this array I store some numbers of my own. So, this is basically my use numbers. So, is basically negative numbers, all are negative numbers, 0 to 30, 20, we can 27, minus 27 is the number. Alternatively, you can load random numbers also. You can just call a random math.random method and then you can initialize this array, that also you can do it. And one important point that you should note, that in case of arrays, we do not have to store as a collection, rather we can just simply pass the primitive array, that means integer array here, because the array's sort method takes the argument as a primitive data type, not that integer object you have to pass it. Okay, so this is the good point that you can note it. And here is basically, okay, you print the array before sorting, then call the sort method on the array, it basically sort, then you can print after the sort. That is all. So, this basically give a idea about how the sort method, which is defined in arrays class, can be used in your program. And here again, thus again you can rewrite the program by writing parallel sort here, also you can run it, but that you can get the impact if you take very large elements stored in the array. So, that okay, you can try of your own. So, these are the different methods, parallel sort and sort. Only two methods are defined in Java collection framework to sort any elements. And another question is that in different collection, if you see, they do not require any sorting explicitly defined, because there are some methods already store the collection, I mean maintain the collection in a sorted fashion. Now, for example, array list also you can make into store the element in a sorted fashion, or either linked list, or even the sorted tree, or any other hash, okay, sorted hash map also, they are basically automatically store the element in the sorted. So, explicitly they do not define any sorted sorting method for that, except this arrays class, which basically includes the sort method defined in it. And okay, so this is now, so this is basically the idea about the sorting using JCF. There is no much information about sorting technique there in Java collection framework, and that is all. For many other programs which I have used in this discussion and the different sorting algorithms which I have covered in this course, you can find from this link. This link is very useful for you. And okay, thank you very much.